Okay, so today we're going to go ahead and we're going to learn by substitution y equals negative 5x plus 2 or y equals 3x minus 14. Okay, now if y equals this and y equals that, I literally could say y equals y, which is true. I could take and substitute all this in for this first one. I'll just call this the first one that they told me. All they're doing is defining y two different ways. It's still the exact same y. It's like saying 4 is equal to 2 plus 2 or 4 is equal to 1 plus 3. It's still a true definition. So I'm going to substitute negative 5x plus 2 equal to 3x minus 14. I wouldn't start you off with fractions, so this one will be much happier. Let me get some colors here. Okay, draw your walls. Disco Moo Moo. It'll look like a repeat. Variables, numbers. Okay, first one I need is no distribute. There's no combine. Let's go ahead and move numbers. So I go to the variable apartment, and I'm moving out this positive 2. So inverse operation. We'll go ahead and subtract 2 from both sides, and then simplify. Negative 5x, that's a 0 pair. They cancel. Equals 3x. Same sign you add. Now I get negative 16. There's the difference. Okay, now we've done that one. We need to move variables. So that means we go to the numbers apartment. We find the variable term. Inverse operation would be minus 3x from both sides. Simplify. We get negative 8x equals much better, Miss Sweat. Oh my God. Okay, now to solve this, because we're done with move, we go to the solve. Divide by negative 8. Divide by negative 8. And we get x equals, it's really a 1x. I usually don't do this step here, but the reason we do this is to force that to be a 1. This will be 2. Oh, much nicer number. I'm like, why would I start off with a fraction? They do get to fractions, but I wouldn't do that to you just yet. Now, we know the x part of our answer. So our answer is x comma y. So we got 2 comma, I don't know what. But what we need to do is take this, subbing today for x is 2. So you'll hear me say plug it in, and I usually do it up over here. I put a squiggly. You take either equation. Sorry, that's my fault. Oh. I'll get to it in a moment. I don't need that. Okay, and what I want to show is that's kind of interesting, and you guys will be like, well, what if I decide to put in the first one or the second one? It doesn't matter, because we're finding the point that when you substitute in that x and that y, that makes both of them a true statement. So I'm going to solve it. I'm going to plug it into both equations and show you. I'm going to do it side by side. You don't have to do this twice. You have to do it once. You pick either equation, one of the original equations, an OE, not an OG. And we're going to go ahead, instead of x, today subbing for x. So this x is going to come out, and this 2 is going to go in. But since I'm doing it 2 of them, obviously I'm going to take it out here. I'm just showing you that it will work in either one. Okay, so now I'm going to go ahead and write these. Y is equal to negative 5. Instead of x multiplying, we're going to say times 2. And I do put parentheses. The reason I put the parentheses is a lot of times you'll mess up negativity. And if you put parens, you're not going to make mistakes. Okay, next up, y. I'll do it over here as well. Going to do it in both. Okay, so y equals negative 5 times 2 is negative 10 plus 2. I get y is equal to negative 8. Okay, now we should get the same number over here. I've told you if you do it into either one, you're going to get the same y. I don't want to lie to you about math. I'll lie to you about anything else, but not math. 3 times 2 is 6. 6 minus 14. Different sign, subtract. Okay, so guess what y is? It's negative 8. So the ordered pair where these are going to meet, if I were to graph these, I assure you that they're going to meet at 2, negative 8.